Hi, it's Katrina. From raining diamonds to super megastorms, here are 8 cases of dramatic weather on other planets. Number 8. Storms as wide as Earth. Known as great white spots, these giant storms resemble the same thunderstorms we experience on Earth, except they're much larger and stretch across the entire planet, alternating between the equator and mid-latitudes. Since being discovered in 1876, great white spots have occurred 6 times on Saturn, happening every 20 to 30 years. Until recently, scientists were stumped when it came to figuring out what causes these great white spots, or why it takes so long for them to go through the stormy process. Research findings from a study led by Cheng Li, a planetary scientist at California Institute of Technology in Pasadena, were released in 2015, and they revealed that storms may be delayed from developing for decades at a time due to suppression caused by water vapor in Saturn's atmosphere. The most recent storm, which was captured by NASA's Cassini spacecraft, began in 2010, and within 6 months encircled the entire planet. It was nearly as wide as planet Earth, and the latitudinal extent of the storm's head was roughly the equivalent of the distance between London and Cape Town. This 2010 storm helped the scientists understand the confusing dynamics between great white spots. Water molecules on Saturn are heavy compared to the hydrogen and helium molecules that make up most of the planet's atmosphere, causing the water to sink down and form a separate layer. This wet layer prevents warm air from rising as it normally would, leading to a lack of convection, the process of hot and cold gases churning in the atmosphere that storms are usually caused by. When the upper atmospheric layer eventually cools and becomes heavy enough to sink, causing warm, moist air to rise rapidly, the great white spot is finally triggered. Number 7. Raining diamonds. A rain shower of diamonds. I bet a lot of people wish they could get their hands on that, except it happens on Uranus and Neptune, and these 2 planets are billions of miles away. The chance that their gems will be harvested, at least during our lifetime, is slim to none. It's still pretty neat though, right? A study published in Nature Astrophysics Journal in August 2017 detailed how researchers successfully recreated the conditions of Uranus and Neptune in a laboratory, and using fancy plastics and high-powered lasers, produced something called diamond rain, which is essentially what it sounds like. In a nutshell, here's how it works. Neptune and Uranus are 17 and 15 times the mass of Earth, and their atmospheres experience pressures millions of times more intense than the air pressure at Earth's sea level. The extreme pressures of the planet's interior splits molecules into hydrogen and carbon atoms, the latter of which crystallize, forming diamonds. In other words, lightning storms turn methane into carbon, which toughens into chunks of graphite as it falls. These chunks of graphite eventually harden into diamonds, some of which succumb to the immense atmospheric pressure and become liquid. Between Uranus and Neptune, scientists estimate that over 1,000 tons of diamonds are being created annually. Until this recent study, scientists had never proven that diamond rain showers on these planets were possible, although they had long speculated about it. But it wasn't the first time diamonds were connected to space. Fragments of a meteorite that fell in 2008 and exploded over a desert in Sudan contain diamonds. And in Brazil, there are carbonado, or black diamonds, that are believed to have resulted from a meteorite crash 3.8 billion years ago. And now for number 6. But first, be sure to subscribe if you are new here and click the notification bell to join the Origins Explained family. Number 6. Jupiter's Great Red Spot. There's a megastorm raging on Jupiter. It's been continuously observed since 1830, but similar reported sightings from as long as 350 to 400 years ago are believed by some researchers to be the same storm. On the other hand, some scholars believe that the storm observed during the 1600s and 1700s was a different one than the one occurring today. Will we ever know for sure? Probably not. Regardless, a storm that has likely been going on for 400 years is quite impressive. The turbulent atmospheres of gas giants such as Jupiter are common places for anticyclonic storms, such as the Great Red Spot, which is twice as wide as planet Earth and rages at 400 miles per hour. By comparison, the 1,000-mile-wide, 200-mile-per-hour hurricanes that happen on our planet seem kind of small. Scientists are uncertain about what gives the Great Red Spot its crimson hue, but it may be caused by sulfur in the atmosphere. According to studies, the clouds created by the storm consist of ammonia, ammonium hydrosulfide, and water. but researchers are unsure if the Great Red Spot's colors are the result of a chemical reaction. They also don't know exactly what causes storms like this, partially because Jupiter is such a different planet than ours. It's 1,000 times the size of Earth and is mostly gas, with an ocean of liquid hydrogen surrounding its core and an atmosphere consisting mostly of hydrogen and helium. Additionally, telescopes and orbiting probes are only able to capture elements of the Great Red Spot that are high in the atmosphere. In other words, mostly clouds and not much else. There is some value to researching the dynamics behind this superstorm, according to planetary atmosphere expert Amy Simon. Despite Jupiter's much different chemical makeup, its weather functions under the same physics as planet Earth. Studying Jupiter and the storm could lead to a better understanding of Earth's weather system and of worlds beyond our solar system. A new sibling storm known as the Little Red Spot, or Red Spot Jr., has emerged in recent years. It was created in Jupiter's southern hemisphere as the product of 3 smaller, white-colored storms. We'll have to keep an eye on it and see what happens. Number 5. Greenhouse effect from hell. It's no secret that Venus is the solar system's hottest planet, with an average temperature of 735 Kelvin, or 462 degrees Celsius. With a surface hot enough to melt lead and an atmospheric pressure 92 times greater than that of Earth, it also sounds like the solar system's most uncomfortable planet. But why is Venus so hot? Put simply, it's because of the planet's runaway greenhouse effect that likely began millions of years ago. When heat radiates from the ground, carbon dioxide in the planet's atmosphere prevents it from traveling back into space. It's essentially the same as if you sat in your car on a hot day with the windows rolled up. No thanks. Scientists believe that Venus used to be more like Earth, with lower temperatures and liquid water, but the planet heated up at some point billions of years ago, causing all of its water to evaporate. Water vapor is a more powerful greenhouse gas than carbon dioxide, causing temperatures to rise dramatically. Carbon dioxide that was trapped in rocks sublimated into the atmosphere and mixed with oxygen. As a result, more carbon dioxide was created. Ultimately, and not surprisingly, Venus's atmosphere became the dense, carbon dioxide-dominated environment that it is today. It's admittedly difficult to collect hard data from Venus, since probes that have landed there were destroyed within hours by its atmosphere. However, computer modeling of the planet's ancient climate, created by scientists at NASA's Goddard Institute for Space Studies, demonstrates that Venus may have in fact once been habitable. The model used by researchers to determine this information was similar to that used to predict future temperatures on Earth. While this doesn't make any positive indications for the future of climate change on our planet, it's unlikely that Earth will become as hot as Venus during our lifetime. Thank goodness. Number 4. Explosions in the sky. Speaking of Venus, it has a lot more going on. Despite being nearly the same distance from the Sun as Earth, Venus is 100 times hotter and its days are 200 times longer than ours. Its atmospheric pressure is similar to that of diving 3,000 feet beneath our ocean surface. Venus also lacks a magnetic field, unlike Earth, and this at least partially affects the Sun's impact on the planet. About 44,000 miles away from Earth, the Sun's solar wind collides with the planet's magnetosphere, which acts as a protective shield that keeps most of the wind from penetrating the atmosphere. Venus, on the other hand, does not have a magnetosphere. Instead, its atmosphere is almost entirely carbon dioxide with thick clouds of sulfuric acid covering the planet. This causes the previously discussed runaway greenhouse effect, which results in temperatures hotter than the surface of Mercury. With winds constantly moving at around 224 miles per hour, Venus's atmosphere resembles a burning hot hurricane with metal snow and rain showers of sulfuric acid. Most shockingly, however, are the explosions, also known as hot flow anomalies, or HFAs, that occur near the planet's surface. They often happen multiple times a day and can be larger than Venus itself. HFAs are so strong, they cause supersonic solar winds to reverse direction. The same phenomenon occurs near Earth on an average of once daily, but because Venus lacks a magnetosphere, its HFAs happen much closer to the planet's surface. Number 3. Supersonic methane winds. On Neptune, it doesn't just rain diamonds. Winds on the blue planet travel faster than the speed of sound. Neptune is the furthest planet from the Sun, unless you cling steadfastly to the outdated belief that Pluto is a planet, of course. and has the strongest winds in the entire solar system. High-altitude winds consisting of clouds of frozen methane travel at 1.5 times the speed of sound, exceeding 1,100 miles per hour. Winds on Earth, in comparison, move at a maximum of 250 miles per hour. On Neptune, some cloud formations, including one known as Scooter, circle the planet every 16 hours. Because the planet's top layer of wind blows in the opposite direction of its rotation, scientists believe there may be a warmer, thick layer of water clouds beneath the methane. The first and only close-range observations of Neptune were made in 1989 by NASA's Voyager 2 spacecraft. In these detailed images, there were bright white clouds along with two massive storms speeding throughout the atmosphere. Composed primarily of hydrogen and helium, Neptune is considered a gas giant. Only 1 to 2% of its atmosphere is composed of methane, but the planet gets its blue hue from how this small amount of methane absorbs sunlight. Number 2. Megastorms. In 2014, the typically placid planet of Uranus experienced a bizarre surge of megastorms, making it the planet's stormiest year on record. The planet had become more active in 2007, when the sun shone directly on its equator. As a result of this effect, scientists accurately predicted a particularly stormy year, but they didn't foresee the chaos that would occur 7 years later. Using the Hubble telescope in August of 2014, astronomer Imke de Pater of the University of California, Berkeley, and her team noticed 8 large swirling storms in Uranus's northern hemisphere. The storms extended some 5,592 miles across and happened at various altitudes. Among them was the brightest storm scientists have ever observed on the planet. De Pater pointed out that nobody expected the storms, and that they are demonstrative of how little is known about our solar system. She also explained that scientists were caught off guard by the storms and had no idea why they were occurring, and that in order to find out, they'd have to see if the storms were happening over the planet's southern hemisphere, a process she admits will take many years and may not happen during her lifetime. Because these storms lack an internal heat source, one theory holds that they were driven purely by sunlight. However, this theory is less than promising, since sunlight is weak in Uranus's northern hemisphere. Number 1. Nitrogen ice clouds. With an average temperature of minus 315 degrees Fahrenheit, the coldest place in our solar system is represented by Triton, one of Neptune's 13 moons. In fact, it's believed by some scientists that Triton and Pluto are similar in composition and may have shared origins. An image of Triton's large pinkish south polar cap, which is thought to possibly consist of a layer of slowly evaporating nitrogen ice, was captured in 1989 by NASA's Voyager 2. As a result, nitrogen clouds are formed a few kilometers above the surface. Triton's crust is also partially composed of water ice. During the 1989 Voyager 2 visit to Triton, scientists observed icy active volcanoes on the moon. Triton also has seasons. Researchers using Chile's Very Large Telescope observed that during the summer in Triton's southern hemisphere, the moon's atmosphere is thickened by the sun's warmth. Yet even more strangely, Triton is slowly inching toward Neptune and has a backward orbit. It's predicted that in 3.6 billion years, long after humans are gone from the Earth, Triton will either collide with Neptune or break up and form a ring around the planet. I guess we won't be there to find out. Thanks for watching! Remember to subscribe and check out other videos about planets and space on Origins Explained. There's a lot more where that came from. See you next time. Bye!